Hey everyone! Today we're going to jump into something that is absolutely essential for any C programmer, file handling. This is how we make our programs, well, remember things even after you've closed them.
I mean, seriously, have you ever stopped to think about it? You quit a game, come back hours later, and boom, your character is right where you left them. Or you type up a huge document, close it, open it tomorrow, and all your words are still there. How in the world does that work? Well, the magic answer is files. You see, when your C program is running, all the data, your variables, all that stuff, it lives in what's called RAM, Random Access Memory. And while RAM is super fast, it's also volatile. And that's a key word. It means the second your program ends, poof, everything in that memory is wiped clean. It's kind of like writing on a whiteboard that just erases itself automatically.
And this slide just lays it all out, doesn't it? On one side, you've got RAM. It's lightning fast but has the memory of a goldfish. On the other side, you have your disk storage, like a hard drive or an SSD. It's a little slower, sure, but it remembers things forever. So to make our programs actually useful, we need to build a bridge between the fast, forgetful brain and the permanent memory. And that bridge, my friends, is file handling.
The good news is it's not as complicated as it might sound. It's really just a simple three-step dance. First, you've got to open the connection to a file. Second, you operate on it. That means you're either reading from it or writing to it. And third, and this is crucial, you have to close that connection when you're done. We're going to walk through all three.
Okay, but wait. Before we can even think about opening any doors, we need a key, right? And in the world of C file handling, our key is a special little thing called a file pointer.
Now, it's so important to get this. The file pointer isn't the file. Not at all. Think of it like a bookmark in a book. The bookmark doesn't contain the story, does it? No, it just holds your place. It tells you exactly where to start reading next. The file pointer does the exact same thing for your program. It just points the way. And in your actual code, this is literally all it is. That file in all caps, that's a special data type C gives us just for this. And that little asterisk, that star, tells C that FPTR isn't a regular variable. It's our special bookmark, our pointer. Okay, key in hand. Now it's time to actually unlock the door to our file. And for that, we bring in our first big tool, the FOPON function. Think of FOPN as your personal doorman. You got to give it two things. First, the name of the file you want to mess with, like filename.txt. And second, the mode, which is just you telling the doorman what you plan on doing once you're inside. And this mode is so important. The big three you'll use all the time are R for read. Pretty simple. You're just looking at what's inside. Then there's W for write. Be careful with this one. It's like taking a bulldozer to the file. If the file exists, W wipes it completely clean before it starts writing. And finally, there's A for append. Append is polite. It doesn't delete anything. It just goes to the very end of the file and adds your new stuff there. Getting this right is everything.
Okay, now listen up, because this is a pro tip that will save you so many headaches down the road. What happens if the file you're trying to read just isn't there? Or what if you don't have permission to write in that folder? Things can go wrong, and your program needs to be ready.
This is why you always have to check your file pointer right after you call open function. If something went wrong, open function won't give you a valid bookmark. Instead, it gives you back this special nothing value called null. And that little if statement right there, checking for null, lets you catch that error and deal with it instead of just letting your whole program crash and burn.
All right, we're in. The door's open, we've checked that it's safe. Now for the real action. It's time to actually have a conversation with the file. We're going to read from it or maybe write to it.
It really just boils down to which way the data is flowing. When you're reading, you're pulling information from the file and bringing it into your program's variables. When you're writing, it's the other way around. You're pushing information from your program out to the file where it can be stored forever.
And see? Well, it gives us a whole bag of tricks for this conversation. And hey, a lot of these should look pretty familiar, right? They're basically the cousins of functions you already know, like printf and scanf. That little F at the beginning is your clue. It stands for file.
So fprintf, for example, works almost exactly like printf. The only difference is that first thing you give it, our file pointer. That tells the function, hey, don't print this to the screen. See that bookmark? Yeah, send this formatted string right there, into that file.
And fscanf is just the reverse. It's like a little data detective. It goes to the file our pointer is marking, looks for data that matches the pattern you give it, in this case a number,
and plucks it right out, dropping it safely into our age variable. You're literally pulling data out of a text file and into your program. Pretty cool, huh?
So, we've had our conversation, we've read what we needed, we've saved our progress, but we are not done yet. We've come to the last, and I mean non-negotiable step, the clean close. So why is this such a big deal? Well, closing the file is what officially tells your computer's operating system, okay, I'm finished, please make sure everything I wrote is actually saved to the disk. It also frees up that file so other programs can use it, and it helps prevent your data from getting corrupted. I mean, you wouldn't just drop a phone call without hanging up, right? This is the exact same idea.
And the best part, it's super simple. You just call the fclose function and give it the same file pointer, the same bookmark that you've been using this whole time. That's it. Connection terminated, job done.
So let's just recap that whole journey one more time. You use fopen to open the door and get your pointer. You use functions like fprintf or fscanf to do the actual work. And you use fclose to hang up the phone and clean up. Open, operate, close, every single time. And that right there is the whole point. This isn't just about learning some random functions. This three-step process is what turns a simple script into a real, powerful application. It's what allows software to save its state, to remember user preferences, to be persistent. It's what gives your program a memory. So, the next time you hit save in a video game or a word processor, you'll know about the elegant little dance of pointers and functions happening behind the curtain. And really, the only question left is, now that you have this power to make your programs remember, what amazing thing are you going to build?